Welcome to Night Cosmos. Before we dive into today's fascinating topic, if you love the mysteries of the cosmos and want to explore more, don't forget to subscribe to our channel and hit the notification bell so you never miss an episode. Today, we're going to explore one of the most intriguing and mind-boggling concepts in modern science. Could the multiverse really exist? What if our reality is just one of many, each with its own unique laws and property? In this episode, we'll explore the possibility of infinite universes and dive into the theories that suggest this idea might be closer to reality than we think. From quantum mechanics to string theory, the concept of the multiverse has fascinated scientists and philosophers alike for years. Join us as we embark on a journey through the mind-bending idea of parallel universes and the possibility that our own reality might not be the only one. The idea of the multiverse suggests that there could be an infinite number of parallel universes, each with its own set of physical laws, constants, and properties. Imagine that every decision, every event, and every moment creates a new universe, splitting reality into multiple versions of itself. This concept, known as the many worlds interpretation of quantum mechanics, proposes that each time a quantum event occurs, such as the decay of an atom or the flipping of a coin, the universe splits into different branches, each corresponding to a different possible outcome. These separate realities exist simultaneously, but we are only aware of the one that we experience. If this theory is correct, it would mean that every possible outcome of every possible event has already occurred in some alternate universe, and that the universe we live in is just one of an infinite number of possibilities. One of the most compelling aspects of the multiverse theory is the idea that our universe, with all its unique properties and constants, may not be as special as we once thought. Instead, it could be just one of many universes that emerge from the same cosmic process. The concept of a bubble universe comes into play here. According to the theory of cosmic inflation, our universe underwent a rapid expansion just after the Big Bang, stretching exponentially over a fraction of a second. This expansion could have created other bubbles or pocket universes, each with its own distinct laws of physics. These universes might be entirely different from ours, with completely different forms of matter and energy. Or they could be very similar, perhaps even containing life forms like our own. The possibilities are endless, and the idea that there are other universes with different laws of physics challenges our understanding of the very nature of reality. The concept of the multiverse also ties into the idea of string theory, a mathematical framework that attempts to explain the fundamental building blocks of the universe. String theory suggests that the particles we observe as fundamental, such as electrons and quarks, are actually tiny vibrating strings, and that the behavior of these strings determines the physical properties of our universe. One of the more fascinating implications of string theory is that it predicts the existence of additional dimensions beyond the 3 dimensions of space and 1 of time that we are familiar with. These extra dimensions could be compacted into incredibly small spaces, hidden from our perception, but they may be key to understanding the structure of the multiverse. According to some models, the different possible configurations of these extra dimensions could give rise to different types of universes, each with its own unique physical laws and constants. The idea that our universe is just one of many, all governed by different sets of rules, opens up new possibilities for the nature of existence itself. Another interesting aspect of the multiverse theory is the possibility that other universes could have different physical constants. In our universe, the constants that govern the behavior of forces like gravity, electromagnetism, and the strong and weak nuclear forces are fine-tuned to allow for the existence of life as we know it. However, some physicists have speculated that in other universes, these constants could be different, leading to vastly different environments. In some universes, gravity might be much stronger or weaker, making life impossible. In others, the electromagnetic force could behave in strange and unfamiliar ways, causing matter to behave differently. These variations in physical constants could create worlds that are completely inhospitable to life. Or perhaps they could give rise to forms of life that are entirely alien to our understanding. The concept of a multiverse with different physical laws challenges our notions of what is possible and expands the boundaries of imagination. One of the major challenges of studying the multiverse theory is the lack of direct evidence. Unlike other scientific theories, the multiverse is inherently difficult to test or observe. Since the universes proposed by the multiverse theory would be completely separate from our own, there is no way for us to interact with or measure them directly. This has led some critics to dismiss the idea as speculative or even unscientific. However, proponents of the theory argue that while we may not be able to directly observe other universes, there may be indirect evidence that could support the idea of the multiverse. For example, some physicists believe that certain anomalies in the cosmic microwave background radiation, which is the afterglow of the Big Bang, could be signs of collisions between our universe and other universes in a multiverse. These faint traces of cosmic history might offer a glimpse into the existence of other realities, even if we can't fully observe them. The multiverse theory also raises intriguing questions about the nature of reality and the meaning of existence. If there are an infinite number of universes, each with its own set of laws and outcomes, then what does that mean for our place in the cosmos? Are we simply one version of ourselves among countless others, each living out a different life based on a different set of choices and circumstances? And if there are infinite versions of us, do they all experience the same sense of self? Or do they exist as entirely separate entities with their own consciousness and experiences? These philosophical questions have been explored by thinkers for centuries, and the idea of the multiverse adds a new dimension to these debates. If the multiverse theory is true, it could mean that the very nature of existence is far more complex and varied than we can comprehend, and that our reality is just one thread in an infinitely woven tapestry of possible worlds. One of the most intriguing implications of the multiverse theory is the possibility that it could offer answers to some of the biggest mysteries of our universe. For example, the fine-tuning problem refers to the precise balance of physical constants that allow life to exist in our universe. If these constants were even slightly different, life as we know it would be impossible. The multiverse theory offers a potential solution to this problem. In a multiverse with an infinite number of universes, it's conceivable that some universes would have the right conditions for life while others would not. This would mean that the fine-tuning of our universe is simply the result of chance, with our universe being one of the rare, fortunate ones that just happens to support life. In this way, the multiverse could provide a natural explanation for the extraordinary conditions that allow us to exist. The multiverse theory also challenges our understanding of the beginning of the universe. Traditionally, scientists have looked to the Big Bang as the origin of our universe. But if the multiverse theory is correct, the Big Bang may not have been the true beginning at all. Instead, our universe could be just one of many that emerge from an ongoing process of cosmic inflation, where new universes are constantly being created. Some models suggest that universes can form from eternal inflation, a process where space-time continues to expand indefinitely, giving birth to new universes within the multiverse. In this scenario, our Big Bang would simply be the beginning of our universe, but not the beginning of everything. This raises questions about the nature of time itself and whether the multiverse has always existed, stretching infinitely into the past. While the idea of the multiverse may seem like science fiction, it has garnered serious attention from the scientific community, especially in the field of theoretical physics. Some of the most respected physicists, including Stephen Hawking and Brian Greene, have explored the concept of the multiverse in their work. These scientists argue that the idea of parallel universes is not only possible but potentially inevitable, given the mathematical models that describe the fundamental forces of nature. The development of string theory, quantum mechanics, and cosmic inflation has opened up new avenues of exploration for the multiverse. And while we may not have definitive proof yet, the theory is gaining traction as a plausible explanation for some of the most profound questions about the cosmos. As our understanding of the universe continues to evolve, the concept of the multiverse may eventually become a key part of our understanding of reality. One of the most fascinating aspects of the multiverse theory is the idea that our universe might be just one small part of a much larger, interconnected structure. In some models of the multiverse, universes are not isolated from one another, but instead exist in a kind of vast cosmic network, where the properties of one universe could influence or interact with others. This could mean that events in our universe are not entirely independent, but are somehow connected to the happenings in other parallel universes. The possibility of interactions between universes opens up new questions about causality, time, and the flow of information. For example, could the actions of one universe affect the development of another? Could events from other universes bleed into our reality, influencing the course of our own history? These are questions that scientists are just beginning to explore, and they could lead to groundbreaking discoveries about the nature of space and time. The idea of the multiverse also raises profound philosophical questions. If the multiverse exists, it suggests that there may be infinite versions of ourselves living in parallel universes. Each version of us might be experiencing different lives, making different choices, and facing different challenges. This raises questions about the nature of identity and free will. If there are infinite versions of ourselves, what does it mean to be us? Are we defined by our choices and experiences, or is there something deeper that connects all the different versions of ourselves across the multiverse? These questions challenge our traditional understanding of what it means to be an individual, and they have been explored by philosophers for centuries. The concept of the multiverse adds a new layer of complexity to these debates, offering a radically different perspective on the nature of self and existence. As we delve deeper into the multiverse theory, it's essential to consider the implications it may have on our understanding of the laws of physics. In our universe, the laws of physics, like gravity and electromagnetism, govern the behavior of everything, from the smallest particles to the largest galaxies. But what if these laws are not universal? The multiverse theory proposes that each universe could have its own set of physical laws, some of which might be radically different from our own. For example, in some universes, gravity might be much stronger, or electromagnetic forces could behave in completely unpredictable ways. This could create environments that are entirely alien to us, and life as we know it might not even be possible. However, this idea also raises the intriguing possibility that different forms of life might arise in these universes, adapting to their own unique set of physical laws. The multiverse opens up a whole new realm of possibilities for what life could look like in the cosmos. Another fascinating aspect of the multiverse theory is its potential to explain certain cosmic mysteries that have puzzled scientists for years. One such mystery is the problem of dark energy, a force that is causing the accelerated expansion of the universe. Despite decades of research, scientists still don't fully understand what dark energy is or how it works. The multiverse theory offers a potential solution. According to some models, dark energy could be the result of interactions between different universes in the multiverse. If universes collide or interact with one another, they could transfer energy, causing certain universes to expand at accelerated rates. This could explain why our universe is expanding so rapidly and why we observe such a strange force at work. If this theory is correct, it would mean that the strange behavior of dark energy is not unique to our universe, but could be a natural consequence of the multiverse's dynamics. The concept of multiple universes also has significant implications for our understanding of time and the nature of the Big Bang. In the traditional model of cosmology, the Big Bang marks the beginning of our universe. But if the multiverse theory is correct, the Big Bang may not be the true origin of everything. Some versions of the multiverse suggest that the Big Bang could be just a moment in the life cycle of a larger, ongoing process. In this view, our universe might have been born from the collapse of a previous universe, or it could be one of many bubbles created in a constantly expanding multiverse. This challenges our understanding of time itself, suggesting that the flow of time might not be linear, but instead cyclical or even infinite. If time is part of a larger multiverse, then our universe could be just one chapter in a much longer ongoing story. One of the most mind-bending aspects of the multiverse theory is the idea that it could explain the existence of parallel versions of ourselves. According to the many worlds interpretation of quantum mechanics, every time we make a choice, the universe splits into multiple realities, each corresponding to a different outcome. In some of these parallel universes, you might have made different decisions, leading to a completely different life. These alternate versions of yourself might live in universes where different circumstances have shaped their experiences. They might have different personalities, careers, and even physical appearances. The idea that there could be infinite versions of ourselves living out different lives raises profound questions about the nature of identity and free will. If there are infinite versions of you, does that mean all versions of yourself are equally you? Or is there something unique about the version you experience in this universe? The multiverse theory also has profound implications for the concept of fate. In our universe, we often think of our lives as unfolding according to a set of predetermined events, influenced by our choices, our environment, and the laws of physics. But if the multiverse theory is true, fate might not be as fixed as we believe. In a multiverse with infinite parallel universes, every possible outcome of every event is realized in some universes. This means that every choice we make could lead to an entirely different version of ourselves in another universe. If this is the case, then our fate might not be a single linear path, but rather a complex web of infinite possibilities. The idea that there are infinite versions of us, each living out different versions of their lives, challenges our traditional understanding of destiny and free will. Another intriguing aspect of the multiverse theory is the potential for the existence of universes with entirely different forms of life. In our universe, life is based on carbon, water, and the chemical processes that support life as we know it. But in other universes, life could exist in forms that are completely foreign to us. For example, in universes with different physical laws or constants, life could be based on entirely different molecules or processes. These alternate forms of life might not be carbon-based at all, but could involve entirely different chemistry. Life could exist in environments that we would consider inhospitable, such as superheated gas clouds, or it could arise in conditions where we can't even imagine life thriving. The multiverse theory expands the possibilities of what constitutes life, suggesting that our understanding of biology may be only a small part of the larger picture of life in the cosmos. The idea of the multiverse also raises intriguing possibilities for the future of humanity. If there are an infinite number of universes, each with its own set of circumstances and outcomes, then the future of humanity could take countless different forms. In some universes, humanity might continue to thrive and expand, colonizing new worlds and advancing to unimaginable technological heights. In others, humanity might face extinction or never arise at all. The potential for parallel timelines in the multiverse could offer a fascinating glimpse into the future, where different versions of humanity experience entirely different destinies. For example, in one universe, humanity might solve the problems of climate change and create a utopian society, while in another, environmental collapse could lead to societal downfall. These alternate futures offer an intriguing perspective on the potential paths that our civilization could take. While the multiverse theory is still a topic of debate among scientists, its potential to revolutionize our understanding of the universe is undeniable. It forces us to reconsider the fundamental nature of reality and our place within it. If the multiverse exists, it means that everything we know about the universe could be just one small part of a much larger, more complex structure. The possibility of infinite parallel universes, each with its own rules and realities, challenges our assumptions about the limits of the possible. It suggests that there may be countless realities out there, each with its own history, physics, and forms of life. Whether or not the multiverse theory is eventually proven, it serves as a powerful reminder of how little we truly know about the cosmos and how much there is still to discover. As we contemplate the vastness of the multiverse, it's important to remember that these ideas, while fascinating, are still speculative. The scientific community is still grappling with the implications of the multiverse theory, and many questions remain unanswered. Can we ever directly observe other universes? If so, how might we detect them? What role does the multiverse play in our understanding of the laws of physics, and how can we test the predictions made by multiverse models? These are questions that will likely occupy scientists for many years to come. Yet, even in the face of uncertainty, the multiverse offers a tantalizing glimpse into the possibility that our universe is far more complex than we can currently imagine. It challenges us to think bigger, to explore the unknown, and to keep pushing the boundaries of scientific discovery. As we conclude our journey through the concept of the multiverse, we are reminded of how much mystery still surrounds the cosmos. The idea that there could be an infinite number of universes, each with its own set of laws, realities, and possibilities, forces us to confront our own understanding of existence. If the multiverse exists, it means that our universe is just one of countless others, and every choice, every event could create a new reality. The multiverse challenges our sense of self, our understanding of fate, and our view of the universe as a whole. While we may not have all the answers, the idea of the multiverse inspires us to continue asking questions and searching for the truth. For now, as you drift off into sleep, may the infinite possibilities of the multiverse fill your dreams with wonder. Good night.